In this video, we are going to discuss about trigonometric Fourier series analysis. So, trigonometric Fourier series, first of all we will define about it. Any periodic signal can be represented as an infinite sum of sine and cosine functions, which themselves are periodic signal of angular frequencies 0, omega naught, 2 omega naught, dash 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 up to infinity. The Fourier series can be written as follows. X of t is equal to a naught plus summation n is equal to 1 to infinity a n cos n omega naught t plus summation n is equal to 1 to infinity b suffix n sin n omega naught t. Here we can write this x of t like this also. X of t is equal to a naught plus summation n is equal to 1 to infinity, it is not 0, 1 to infinity a n cos n sigma naught t plus b n sin sigma naught n t. Here a naught, a n and bn, these are called Fourier series coefficients, and we need to determine these coefficients using the following formula. An is equal to 1 by t integration over t naught to t naught plus t x of t into dt. Bn is equal to 2 by t integration over t naught to t naught plus 1 x of t sin n sigma naught t into dt. An can be determined using this formula. An is equal to 2 by t integration over t naught to t naught plus t x of t cos n omega naught t into dt. So we have analysis and synthesis equation. Based on this analysis and synthesis equation, we are going to determine Fourier series coefficient and also reconstruction process. So we will discuss two problems in this particular video. First problem, find the trigonometric Fourier series for the given periodic signal x of t shown in figure. So here, when this is actually a train pulse train, and this is a periodic signal, and the signal starting from -1 to 3, this particular signal is repeating over each and every time period. So it's a periodic signal, so we are going to consider a portion of the signal, that is one period of the signal. Based on one period of signal, we are going to find a Fourier series coefficient. So first we have to write mathematical expression for this for this particular waveform. Using that, we are going to find out Fourier series coefficient. So here time period of this waveform is t is equal to 4. Since the waveform starting from -1 to 3, so -1, that is 1, 2, 3, 4. Hence the time period of this waveform is 4. The same waveform is repeating over each and every time period, that is each and every t is equal to 4. So we are going to choose one period of this signal starting from -1 to 3. Okay, here in the Fourier series coefficient determination, we have integration limit starting from t naught to t naught plus t. So we are going to consider t naught is equal to -1 and t naught plus 1 is equal to 3. So t naught is equal to -1 and t naught plus t is equal to 3. And we have to find out omega naught, that is angular frequency. Angular frequency is equal to 2 pi by t. T already we have obtained. T naught t is equal to 4. when we are substituting 4 in this equation, you will get 2 pi by 4 is equal to pi by 2. First of all, we have to replace this sigma naught in Fourier series equation, and then we have to integrate over this duration, that is minus 1 to 3, to find out Fourier series coefficient. So first of all, you will see the formula to find out an, bn, a naught. So this is x of t equation, that is trigonometric Fourier series equation. X of t is equal to this we have discussed. Okay, now mathematical expression for the given signal, given graphical representation is x of t is equal to plus 1, that is plus 1 during the interval minus 1 to plus 1, that is minus 1 less than or equal to t is less than or equal to 1, and minus 1 during the interval 1 to 3. So this is the mathematical expression of given waveform, that is portion of the waveform, and the same thing repeating over each and every time duration. So it has a positive side and negative side. Positive side over the duration minus 1 to t, sorry, minus 1 to plus 1, and negative part from 1 to 3. Now first we are going to start with a naught. So this is the formula to find out a naught. A naught is equal to 1 by t integration over t naught to t naught plus capital T x of t into dt. So we have already determined x of t. I mean we have already find mathematical expression for x of t. X of t is here plus 1 and minus 1 over some duration, and we are going to substitute this x of t in this equation. So we are going to split the integration, that is t naught to t naught plus t, into two intervals. One is minus 1 to plus 1 and 1 to 3, because it has positive and negative quantities. Positive over minus 1 to plus 1 and negative over 1 to 3. So this expression, that is a naught is equal to 1 by t integration over t naught to t naught plus capital T x of t dt, is written like this. So I am going to substitute the upper and lower limit. So a naught is equal to 1 by t integration over minus 1 to 3 x of t into dt. So this integration I am going to divide. So I am going to rewrite this equation like 1 by capital T integration over minus 1 to 1 x of t into dt, and again 1 by t integration over 1 to 3 x of t into dt. So we know that t is equal to 4. It's the time duration. Okay, now so we are going to substitute the value of x of t over this duration and next duration. So first duration, that is minus 1 to plus 1, the value is 1, and second duration, that is 1 to 3, the value is minus 1. I'm simply substituting and then integrating this equation and finding the value. So when we are integrating this equation, I will get 1 by 4, that is after substituting the value of t, 1 by 4. So integration value is t, upper lower limit is minus 1 plus 1 plus 1 by t. When you are integrating this equation, you will get minus t, upper and lower limit is 1 and 3. So we have to substitute upper and lower limit. You will get this 1 by 4, 1 minus 1 plus 1 by 4 minus 3 minus 1. Okay, so a naught is equal to 1 by 4. When we are adding this, you will get 2. Okay, 1 by 4 into 2. When we are adding this, you will get minus 2. Okay, there is minus 3, minus into minus plus, minus 3 plus 1 is minus 2. So now 2 cancel, you will get 2, and 2 again cancel 2. So 1 by 2 minus 1 by 2, which is equal to 0. So a naught value is 0. Now we are going to find out an. An is equal to, the formula to find out an is equal to 2 by t integration over t naught to t naught plus t x of t cos n omega naught t into dt. So now we are going to substitute the value of omega naught and also the limit. The limit is minus 1 to 3, t value is 4 and omega naught is equal to pi by 2. So after substituting I'll get this equation. Now we are going to split the integration into two different parts because it has negative and positive side. So positive over this duration, that is minus 1 to plus 1, and negative over this duration, that is 1 to 3. After substituting I'll get this equation. Then we have to integrate cos n by 2 t into dt. Okay, when we are integrating cos n by 2 t, you will get sin n by 2 to n by 2 t divided by this portion, that is n pi by 2. Okay, and upper and lower limit minus 1 and plus 1. Similarly, when you are integrating this, you will get sin n pi by 2t divided by n pi by 2. So here this minus 1 will come out. So, and after integrating we have to substitute upper and lower limit. So when you are substituting upper and lower limit, and when you are taking these two are common, that is n pi by 2 is common, I am going to take this out, this outside. So I will get 1 by 2 1 by 2 into, when I am taking denominator common part, okay, denominator part outside, and when you are changing denominator and numerator, I'll get n by 2 will become 2 pi by n. So first when you are substituting 1 in this equation, I will get sin n pi by 2 minus lower limit is sin minus n pi by 2. Similarly, the second term minus sin, upper limit is 3, so 3 pi by n, and the lower limit is 1 plus, that is minus into minus will plus. So here minus is there. So when you are multiplying minus and minus, the term will become plus. So plus sin n pi by 2. So lower limit is 1 here. So sin pi by 2 is 1. Okay, and when you are substituting different values, this n, for example, when you are substituting n is equal to 0, sin 0 is 0. So when you are substituting 1, sin pi by 2 1, and the thing will change, plus 1 minus 1 something like that change, and we do not know anything about this n. Now we are not going to substitute it. So simply we are going to assume this sin n by 2 as it is, and minus, here we have sin minus n pi by 2. So sin of minus n pi by 2 we can write minus sin n pi by 2. Okay, so this will become minus, hence minus into minus, this term will become plus. Now we have sin 3 pi by 3 pi n by 2. Here we can write this sin 3 pi n by 2. This is equal to, this term is equal, we can write like minus n pi by 2. Okay, so this will become minus, and we can write this term as sin n pi by 2. Now we have we have this term, last term, plus sin n pi by 2. Now we have 4 sin n pi by 2. So I'm adding all these terms, and I'm going to write like an is equal to 4 pi n pi sin n pi by 2. So this is the first coefficient, second coefficient, that is an coefficient. Now we are going to find out bn. Bn is equal to 2 pi t integration over t naught to t naught plus 1 t naught plus t x of t into sine n omega naught t into dt. So now we are going to substitute the value of t and sigma naught and also the upper and lower limit. So upper and lower limit is minus 1 to 3. T naught t is omega t is 4 and omega naught is equal to n pi by 2. Now as previously what we have done, we are going to separate the integration into two different set, that is minus 1 to plus 1 and 1 to 3. And of course you know that during this interval the value is 1 and during this interval the value is minus 1. Now we have to integrate this equation. There is no change in the constant part 1 by 2 as it is, and now when you are integrating sine n pi by 2t, we will get minus cos n pi by 2t divided by the constant term n pi by 2. So upper and lower limit is minus 1 plus 1 plus we have minus 1 into the same thing sine n pi by 2 integration minus cos n pi by 2 t divided by n pi by 2. The upper and lower limit is 1 and 3. Now the common term I am going to take outside n pi by 2. N pi by 2 will become 2 by n pi. So we can cancel this 2 and you'll get 1 by n pi, and we have four different terms. That is, first term is when we are substituting upper limit you'll get cos n pi by 2. When we are substituting um, lower limit cos minus n pi by 2. Then the second term upper limit is 3 pi by 2, up lower limit cos n pi by 2. Here the value of this one is so these two will cancel, so plus and minus these two will cancel because cos n by 2 n pi by 2 and the same cos minus n pi by 2, so both are same in fact. Okay, cos n pi by 2 is equal to cos minus n pi by 2, so the value will become 1 only, so these two will cancel, and these two, when you are adding these two things you will get 0. Similarly, cos 3 n pi by 2 is equal to cos n pi by 2. Okay, so this is the formula of trigonometric formula. So these two, when you are adding these two things you will get 0. So the final value is, when you are adding all these terms you will get 0. So bn, the second coefficient bn is equal to 1 by n pi 0, so you will get 0. Now we have to substitute the value of a naught, bn and an. So here a naught is equal to 0, bn is equal to 0. We have only one coefficient, that is an. An is equal to 4 pi n pi sine n pi by 2. So for even value of n, the coefficient is equal to 0. Odd value, in particular 1, 5, 9, 13, this particular value, the value of this particular coefficient, that is an, is 4 by n pi. At the same time, when you are substituting n is equal to 3, 7, 11, 15, the value of an is minus 4 by n pi. So this is the coefficient, and the final equation is x of t. When you are substituting this an in x of t, you will get x of t is equal to summation n is equal to 1 to infinity a suffix n into cos n pi by 2t. So now we are going to substitute these value in this equation. So first value is n is equal to 1. When n is equal to 1, an value is 4 by pi, 4 by pi. Okay, when n is equal to 2, automatically the value will become 0 because sine pi is 0. Sine pi, when you are substituting n is equal to 2, what will happen is 2 by 2 cancel sine pi is equal to 0. When n is equal to 3, you will get this term that is equal to 0 minus 4 pi 3 pi. So when is equal to 3, this is a3 and a5, this is a7. So a3 minus 4 by 3 pi, a5 plus 4 by 5 pi, and 7, the 7 minus 4 by 7 pi, and the series will go up to infinity. So this is the trigonometry Fourier